COMPREDICT, and together with Marcel Bachmann, our product manager for vehicle dynamics and research, I will guide you through this webinar today. Let's have a look on our agenda for today. First, we want to give you a short overview about the company COMPREDICT and then also about our virtual sensor technology. Then you will learn how to obtain new vehicle insights with 100% software. You of course get also answers to the most common FAQs. We will close the meeting with what you can take away and how of course you can continue your journey with COMPREDICT after these sessions. We are really happy to guide you through. Thanks for joining. And I would say, here we go. First topic, COMPREDICT. COMPREDICT is a company based in Darmstadt, and we are doing virtual sensors. Virtual sensors use readily existing vehicle data, and we are feeding our models with them to get insights that are normally can only be generated by hardware sensors or are even not obtainable via hardware sensors. This means we're using existing CAN signals in the vehicle like wheel speed, acceleration, brake pressure, and it's normally like 10 to 15 signals we are using. We are feeding our models, and then we are ensuring with our USP, our data science and machine learning knowledge, the accuracy of these models, and also through our automotive domain expertise, the robustness of these virtual sensors so that our customers around the globe can use it in serious production vehicles. The insights we are generating are enabling new SDV capabilities. We can replace hardware sensors, and we can enhance the after-sales business for our customers. But more on this later. Today we will focus especially on enable new SDV capabilities. Some facts about the company. So we are COMPREDICT, the virtual sensor company. As you may already noticed, our technology is 100% software. This means that our customers do not need any additional hardware to use our technology. Also, we are backed by Toyota, Woven Capital, which are invested in us in our Series B last year, and we are trusted by the Renault Group. Renault Group, this means Dacia, Renault and Alpine, where we have a series production contract over 10 million vehicles for our virtual sensors for tire and brake wear. We're working with OEMs around the globe, and we are 100% compatible with any software-defined vehicle. Also, we are really proud to have a strong partner network in place. Just to mention some, for example, NXP, where we are really trying to deploy our AI models at the edge. I will elaborate on this also in this session today, but also Sonatus with their new AI Director middleware to bring our technology into the vehicles. And this only to mention a few out of our partners. So what can we do with our virtual sensor technology? As I said, we can provide new SDV capabilities where we are really talking about generating new insights which were not possible before. This means we can also, with our technology, drastically reduce R&D costs because we can virtualize R&D equipment and bring it at scale, and not only for a few prototypes, but we can also obtain R&D functionalities in production vehicles. This means where you normally nowadays only have hardware sensors in R&D to have like different signals. For example, for wheel force transducer, you are not allowed to drive an open road. We can virtualize it. You can put it as a customer into your vehicles and get all the insights on the vehicles on the road. So this is completely new field we are opening with this topic. And of course, it brings a lot of opportunities. But on this, our product manager, Marcel, will elaborate on this further during the next slides. The second pillar, where we had our last webinar on, was hardware replacement. There, everything is about lower the total cost of ownership, where our customers can reduce the bill of materials and replace actual hardwares to save millions at scale. And the third pillar, our after-sales business. Here, everything is about increasing the loyalty of the OEMs customers through example, information on actual tread depth and also forecasting for end-of-life components like tire wear or brake wear. But today we're focusing on new SDV capabilities, and this is where I hand over to Marcel.
Yeah, thanks so much, Stefan, for this really great overview. And we will now find out how to obtain new vehicle insights with pure software. And for this, we will dig a bit more into one specific sensor out of our whole portfolio you can see here, which is the wheel force transducer visual sensor. So the thing with this wheel force transducer visual sensor is that it is actually very expensive. Yeah, it is used to measure, as Stefan already described, the different forces and torques acting on a wheel. And because it is so expensive and you're actually not allowed to drive it with it on an open road, you are normally limited to only test vehicles and R&D data. Next slide, please. But with our technology, we are able to virtualize this physical measurement sensor to predict forces and torques acting on a wheel in real time, which then can also be deployed into production vehicles to get really the forces and torques acting on a wheel on public roads and in production environments. Next slide, please. This enables a whole new set of very interesting use cases. For example, think of durability engineering. Normally in durability engineering, you can only estimate the stress the components have to take in a production environment. And thus you have to over-engineer your component to a certain degree to be sure it will be able to take this stress. With our solution, you can get the actual forces and torques, the actual component stress in production environments, and thus more efficiently engineer your components. As a second use case, our solution can also be very interesting for fleet management. Here, it enables accurate monitoring of component stress, which can then be used to enhance the service timing and also enable some usage-based pricing models, for example. Regarding vehicle dynamics, our forces and torque data can be used to enable development and calibration of really advanced chassis systems that deliver a superior ride quality that is really tailored to the actual customer usage. Also, an interesting field is at the moment vehicle motion management. You hear it all the time at the moment, and here our solution can be used to leverage the full potential of these vehicle motion control algorithms and to deliver superior performance for enhancing the safety, agility, or comfort of vehicles. But how good is our solution actually? Here on the following slide, you can see some specifications. You see the longitudinal, lateral, and vertical force of a measurement of a wheel force transducer. The reference measurement you can see it's a blue line, which is actually hard to see because the visual sensor we predicted is the orange line, and you can see it maps quite closely with the reference measurement, so that we actually have only an RMSE of only 0.35 kilonewton, which is very accurate. So if you now decide to do a project with us and to calibrate the wheel force transducer on your own, how do you go with this? Next slide, please. There are basically two ways of working with us. Either you already have some existing wheel force transducer measurement data, or you want to do a new measurement campaign. Option one would be that you first provide us the data, share the CAN data and the reference measurement, And then we will do some data validation. You will check the quality of your data against our requirements. And then we actually can start right away with the virtual sensor calibration. The second option is that we do a measurement campaign. And here, normally you start with the campaign setup. The test vehicle gets equipped with the reference sensor and some loggers with the CAN connection. Then the data collection would start where a test driver performs some maneuvers on a test track or open road. And after that, we would process the data and store it. And after that, also we can also start with the virtual sensor calibration. We also, next slide, please. We also have some a lot of customer examples. For example, here we want to mention Alpine, where we already did a virtual sensor, a virtual vPOS transducer project with them to be able to access the force and torque data from multiple development vehicle. And this was a very successful project where we were really accurately predict their vPOS data. And on the second page and second side, you can also see our joint presentation with Suzuki. Here we collaborated on a white paper on the implementation of virtual sensor for visualization of vPOS transducers. If you are interested in this white paper, please just contact Stefan or myself after this webinar, and we are super happy to share it with you. Now I will send over again to Stefan, who will speak about some integration examples and the Q&A. Thanks.
Perfect. Thank you very much, Marcel. Of course, we're really proud not only on our customers, but also on our partners. And of course, when you have such a technology, it's always about, okay, how can I integrate it? We are really flexible. As mentioned, 100% we can go for any kind of architecture in different ways. But also, of course, we have a strong partner network and where we are really closely, for example, working together with NXP, where we showcased really fresh for 2 weeks at the NXP Detroit Tech Days, together with them, the integration of a wheel force transducer on actual automotive grade hardware, which mean that we using the NXP S32K5 microcontroller to get our virtual sensor run. And this was made super easy by the EIQ Auto development toolchain, which we used, which optimizes the model for use cases. So you see that the model, even if it's a high amount of machine learning, is really going for the stuff our partners in the zonal architecture are building on and which can easily be integrated to our customers. So this is where we have a really strong benefit about letting our ML run on zonal architecture together with the EIQ Auto toolchain, which makes it really easy for us to integrate this stuff and deploy it on actual series production vehicles. So this is one way of how you can, of course, get into the world of wheel force transducer into series production and how you can deploy it. If you're interested in this collaboration, maybe also want to talk with NXP and us together on the deployment of WFT, please feel free to reach out at any time and we are happy to talk to you. But also we have in our new SDV capabilities, and because of timing, we will not talk today about this one, but maybe about in a next webinar. So we really focus today on wheel force transducer. We will also give you now in the next section the answers to the most common FAQs, but nevertheless also in our portfolio for new SDV capabilities. We have our damper forces, tie rod forces, drive shaft torque, and also vehicle mass. And what you can see on the right, this is our demo car, our COMPREDICT. Maybe some of you have already seen it at some events. We are really happy to showcase it at any time to our customers. But if you're interested to experience our virtual sensor technology, also get in touch. and we are happy to provide a demo on this one. Now, coming to the next point, so that you really get the answers to the most common FAQs. First of all, we have the question, and we always get it, what kind of data is required to run the virtual sensor? And as I already said in the introduction, we only use readily available CAN signals, which means that we do not need any fancy new signals. You just need to wait for some architecture or something like this. Everything is there. So we are really there to make the most out of your existing signals that are, I'm pretty sure, in 99.9% of all the series production vehicles, we are talking about wheel speed, acceleration, brake pressure, and some kind of stuff like this. So we only use this one. And we also, of course, have a list. We are happy to provide you in the deeper customer talks into the required and optional signals and parameters we are using. But we are pretty sure you have everything in place and we can directly start. Second question we often get is, what is the required minimum sample rate of input data? The minimum requirement sample rate is 10 Hertz. Of course, we can also go up to 100 Hertz, for example, because the higher the requirements to the dynamics of the virtual sensor, the higher must be the sample rate of the inputs. And then, of course, we are happy to talk about your use case, what's the accuracy that is needed, and also to make a decision together with you on which frequency do we want to go to ensure the accuracy you need. Third question, what technology is used to create the virtual sensors? Machine learning. So yes, for our virtual sensors, as you have seen, we combine our unique selling point of automotive domain expertise we are having, but also our expertise of machine learning algorithms. So we combine both. So we deep dive into our models into the physical world, but also in the machine learning world. We combine best of both worlds to calibrate the virtual sensors. And this is, of course, our core strength. The next question is, where is the virtual sensor running? Together with our partner NXP, you already have seen a successful integration example. But also, of course, there are other ways, and we are happy to talk with you about your architecture, how we can integrate it together. But one important message for this one, there is no additional ECU required. We are really flexible with our integration, and we have different ways we can talk with you together and find your suitable integration and deployment option for your vehicles. And of course, also really important to say, this is not a cloud case. This is really a case running deeply in series production vehicles. How many calibration versions per virtual sensors are required for various vehicle variants? This, of course, depends on the variation of influential vehicle design parameters. So normally what we are saying is, if you calibrate for one platform, you can use it along the platform. So this means that if not influential parameters are in the game, we do not need to calibrate again. So for example, if the basic design, for example, vehicle weight, suspension of one platform is similar, the chances are super high that you can just use it. But of course, we can also talk this case by case together with you, our customers. And how does the virtual sensor licensing work? So virtual sensors, as said, are really there to run in the vehicle. This means we license our IP on a per vehicle basis. Of course, we first start with a POC together with you to calibrate the virtual sensors. And then once calibrated, we put it together with you into the series production vehicles, and we have an IP licensing per vehicle basis. These were our FAQs and the answers, of course. Now, maybe before we close the session, what you can take away from the session. So the first point I want to underline is that virtual sensors unlock hidden insights in every series production vehicle. This means hidden insights. You need nothing new. Everything is there. We're using what you have, and we make the most out of it and generate completely new possibilities and insights for you. Also, modern software solutions use only existing vehicle data to deliver new vehicle insights. This means 100% software, no new data. These are the key takeaways we also want to give you today. And last point, of course, how can you continue your journey with COMPREDICT? Thanks again for joining this webinar. And we are really happy to discuss your use cases, your application areas, the starting of POCs, how we can bring our virtual sensors into your series production vehicles. And we are really happy to shape the future together with you. To contact us, of course, you can always write us on LinkedIn, but what is even better, use sales@compredict.de to contact us. We will get in touch, and then we can discuss your use cases. Also, I want to mention that this was the third webinar in our series. The first one, as I said, was on after-sales solutions. We uploaded the stuff. You can watch the recording, use the QR code here to watch it if you missed it. Also, webinar 2, where we are talking about hardware replacement, for example, for headlight leveling and tire pressure monitoring systems. We also uploaded this one so that you can watch it at any time. And today you followed the new SDV capabilities. We gave you a company overview. We talked about the wheel-force transducer and also showed that we also have other things in our portfolio in the new SDV capability section. So we will also upload this so that you can watch all the webinars on YouTube. And we are really happy to discuss with you your use cases. So thanks a lot for joining today, and hopefully we talk soon.